Okay, everyone, thanks for joining again. This is Jonathan Berry. Today's webinar is on regression testing. This is the first in our deep dive series on performance testing. We're going to use our 21-minute format. We'll likely go a little bit longer than that today because there's quite a bit of material, but we'll go through it pretty quickly. And we'll take any questions at the end, and if there's any questions that we're not able to get to at the end of the session, we will definitely email everyone directly back after. So good. Let's first take a quick look at our agenda. So for those who aren't familiar with us, we'll talk a little bit about who we are as a company, get a little bit of background on the types of performance testing as it relates to regression testing, and then we're going to get into the details of what regression testing means, how to design the tests, how to execute them, and maybe most importantly, what to do with the results. Okay, so a quick background on us. Myself and our entire team are form up of former Hyperion developers, technologists, subject matter experts. We exist to serve the enterprise software space with a comprehensive solution for performance management. The Accelatis performance management platform offers standard capabilities around reporting, alerting, provisioning, and on top of the platform we have built a series of business modules, including day-to-day management, automation for both the business as well as IT, the ability to audit both infrastructure as well as business applications. We have a comprehensive log management capability. The whole idea is to manage all logs regardless of whether you have one product or multiple products, doing it all in the same way. We have a deep capability in the performance monitoring space. We take both a generic approach that many other point solutions do, as well as a deep application-specific approach for specific technologies, including IBM Cognos, Hyperion, and others. We also have a broad user experience monitoring capability, and this is kind of showing you who's doing what in the environment. It's a nice complement to performance monitoring. Another key thing we're talking about, and this is part of what we're talking about today, is the performance testing suite. So really everything from stress testing to regression testing, really anywhere where you traditionally think about using load runner, Accelatis can come into play. We also have support desk capabilities. We're going to have a webinar in 2 weeks talking about help desk in general and how it can be an important part of enterprise software deployments. And we will discuss the Accelatis help desk as well and how it integrates into the rest of the performance management platform. We now offer comparative benchmarking capabilities. So the idea is to understand where you fit in with the rest of the community and being able to help decision makers make good decisions based on the experience of what others have done. And then lastly, optimization. This is definitely Hyperion specific, HFM and S-base tuning of business calculations. So this is our product platform and our capabilities. It's built on top of platforms that you know. So we talk a lot about Hyperion. That's what we're going to be talking about. Our specific examples we'll be discussing today is Oracle Hyperion. We also support Cognos as well as a suite of any other enterprise software application. And of course we work with all flavors of Linux and Windows and virtualized capabilities. Okay, so enough about us. Going on to performance testing. If you saw our webinar a couple weeks ago on a high-level view of performance testing, this will be familiar. And it's really just the basic premise that the best managed environments that I've seen, both while at Hyperion and beyond, all leverage performance testing throughout the life cycle. And what that really means is that whether it was with a stress testing view of the world or whether it was day-to-day operations, performance testing can be leveraged in a number of ways to really get a handle on how an environment performs and really enabling clients to be predictive about what's happening in their environments. Okay, and one one common point is that we encourage people to think about performance testing as more than just stress testing, and you must buy into that or you wouldn't be on this webinar. And it's really to look at the different ways that performance testing can play a role in an environment. And one bad thing is to say, oh, performance testing is just there to stress an environment. It's even worse when people do stress testing just because it's a checkbox on a project plan. So in our other webinar, which is now posted I think on our YouTube channel, or you can contact us to get a recording of it, we talked about different types of performance testing, and one in particular that we're going to go into details today is on regression testing. Okay. So another thing to point out is that whether it's regression testing or any other type of testing, is that needs change throughout the life cycle of a deployment. So all these different types of testing, they may not fit all the time. So regression testing is particularly useful once you've gone live. It actually can be used during as an application is being built or doing a migration. But just know that the things that we promote, we don't assume that they're going to be used, that every one of them is going to be used all the time. And first, a word on what regression testing is. So you might hear this by different names. Some people, although I think it's a little bit different personally, they might call it a smoke test. Regression testing is really about checking on a regular basis whether any elements in your application have regressed from a functional standpoint or from a performance standpoint. And really what it is, it's on a regular basis to test certain data points. A data point could be a form, it could be a calculation, it could be some type of report, and it's to check them on a regular basis under certain conditions and determine whether the performance or functionality has deviated from a controlled baseline. Okay? And we're going to get into more details about how to schedule it, but the idea is that this would be on a regular basis. Maybe it's nightly, maybe a little bit less frequently, and the idea is to be able to do this in an automated way. It'll be very inexpensive if it's done in an automated way, and that have a mechanism to compare results with historical data. Okay, so where regression testing fits in, this is a typical implementation schedule, very conceptual. As you can see, the black boxes are the different steps of an implementation, whether it's preparing, whether it's installing the software, whether it's configuring it, building your app, rolling out, and so on. The blue boxes are where performance testing can come into play, and you can see here that there's much more than stress testing involved. So we can do baseline testing early on, capacity and stress testing as we get closer to the rollout. We can do performance comparisons, longevity testing, and so on. What you see in the boxes that are flashing blue and yellow are where regression testing comes into play. So on the upper side of the line, you can see health checks, and we'll talk a little bit about that as well. And the idea of a health check is that it's going to run all through the day on a regular basis, where regression testing is taking a bigger sampling of data points and running them on a regular basis, maybe it's daily, and comparing the results. Okay, and this is what we're going to focus on. And we decided to do the regression testing webinar first because the clients that I've seen, whether they used Accelatis or whether they used LoadRunner or whether they did it manually, the Hyperion clients that integrated regression testing into their regular deployment lifecycle had the best managed environments I've ever seen. So I felt that it's that important. Let's cover this first. And then later on we'll get into webinars on longevity testing and baseline testing and so on. Okay? So first, and I'm a big believer in before we just do anything, we have to figure out why we're doing it. So what are the goals for doing a regression test? And it's really about, and I don't like to just read slides, but it's important, reducing risk while minimizing cost. Okay, so how can we lessen the risk, but we also don't want to spend a lot on it or too much on it. And then we also want to maximize our coverage. So it means we want to make sure that our system's covered, but we don't want to impact the system. These are all conflicting requirements, so we have to be smart about how we do it. Okay, so let's take a look at the cost versus risk first. Okay, so if we were just to run regression tests and we were going to do it manually, let's say, meaning that there was no automation involved and that it had a real cost associated with it, meaning we had to manually do something on a daily basis or we constantly needed changes to it, the cost versus risk line is pretty linear, meaning we could reduce risk, but the more risk we reduce, it's going to cost us more and more because we're spending that much more time on it and investing that much more in it. But with an automated tool suite, we can push the risk down while minimizing the cost. And the idea is really to, as we get into it, to think about, make an educated decision about how much we want to automate, because we could spend an incredible amount of time and money and automate everything and really reduce the risk, but there is a cost associated with it from both impact as well as dollars and time standpoint. So it's really about finding the sweet spot of what makes sense for you and your environment, where you are right now in your life cycle. And again, this may change. There might be times when you move up or down the line. Okay. Another one is coverage versus impact. Okay, so without considering the impact on your environment, meaning what performance hits are we going to take, is there any downtime, these sorts of things, it's easy to go say, yeah, let's regression test everything. Okay, but again, there's a cost associated with it. So if we aren't smart about the tests that we plan and we're just going to take a random sampling of everything, again, this line is pretty linear, meaning we can have more coverage, but the more coverage we have is going to have a bigger impact on our environment. The impact being performance hit, resource usage, downtime, these sorts of things. Okay? But if we're smart about the tests that we pick and we pick certain data points that are going to be representative of larger data sets, then we can really minimize the impact while maximizing the coverage. So once again, it's about finding the sweet spot, and what's right for you might be not right for the people down the street, and it might change over time. So these are the things we need to think about. Okay? So you really have to decide what is your risk tolerance, and that's going to help determine how much you spend in both time and money and process. Okay? So another thing we want to do is when we're building the test, we have to think about what is each test going to tell us. So I've seen people, whether it's stress testing or regression testing, spend an awful lot of time and group time in designing tests without really thinking about what's the goal of the test, what are the results supposed to measure, what are they going to tell us, and what are we going to do about it. So really want to think about what we're trying to get out of it, and to do that we need to think about what our coverage areas are. So for example, we could run a set of regression tests which are purely focused on the business and whether our calculations are working, or we could take a technology view of the world. So coverage, we want to think about, are the regression tests going to cover, and this is kind of a typical enterprise software infrastructure layout is it going to cover the web tier, the app tier, the database, and the network? And you may decide that one or more of these is not critical for you at this point in time, but you should go into that, again, consciously. And also not assume that just because you're doing a simple regression test that you're covering everything. So it's really about having the insight and knowledge as to what you're actually doing. From different aspects of the system, are we really looking to regression test performance? Are we trying to make sure that data hasn't changed? There's a thing called data tie-out. This was a big thing when we were developing tools like financial reports and financial management, is I always wanted to make sure that when we tweaked the rules engine that the data was going to tie out, that we weren't doing something that would report data differently. Very important. Okay. The same thing, are we going to look at product functionality? Are we looking at application details? Are we checking to see whether features function the same way? So it's really kind of a matrix of things that we can look at, and again, we have to be conscious about what we're trying to get out of the test. Okay, so then we want to go in and define some key indicators. Again, this, regression testing is not Hyperion specific. This particular webinar is using Hyperion as an example, so we're going to talk about S-Base, planning, HFM. In this case, each one, we should look at each product, and regardless, again, whether it's IBM Cognos, whatever, and decide what are the things that are really good indicators for the rest of the system. So for S-Base, obviously looking at business calcs, okay, whether it's Maxell, scripts, or calcs, that's a pretty good indicator as to how the S-Base engine is performing. But we also want to maybe look at how some data retrieval stuff is performing, and maybe we use SmartView for that. Okay, so HFM, we might want to look at the end user standpoint and forms. We also want to look at, again, the calcs, the consolidations, whether it's one user or 10 users. So we want to be smart about what types of tests that we pick as key indicators, knowing that these are going to be the canary in the coal mine. If there's a problem with these, then it's likely going to be a problem someplace else. So we don't want to pick tests that, if it works, it's not going to be indicative of other systemic performance. Okay, now identify triggers. Okay, great. So we're going to pick a bunch of tests to run. Okay, now we don't just run them. We actually have to say, well, what is worth investigating? And we want to be, again, conscious about this. So we don't want to define a trigger to say, oh, if my calc runs in more than 5 seconds, that's a problem. Well, maybe it is, but you should also think about what are we going to do about it if there's a problem. And if you have no action plan and you're not going to investigate, then maybe it doesn't make sense to set triggers that are super aggressive. Okay. Likewise, we need to understand what are normal operating ranges. So to set a trigger, if 90% of the time performance is within a certain range, and you're looking for that outlying 5 or 10%, you have to understand what the normal operating ranges are, and generally you need some quantifiable data for that, whether it's a performance tool like ours or someone else's. Again, don't set a test to fail if a report takes 10 seconds if it normally takes between 8 and 12, because then you're just going to have a lot of false positives. So what I'm trying to get at here is really be conscious about the types of tests we create, think about how we're going to design the test, and think about how we're going to evaluate the results. Okay, so now look at how broad the test should be. So it might be that we're focused on a product, or maybe we're looking at the whole suite. So this again comes down to coverage, and when we have a test suite, we may decide that, hey, we're going to run the entire suite of tests on a weekly basis, but whenever we make a particular change, we're going to focus just on that set of tests. So you might look at it breaking down the set of tests into components and things that affect different areas, whether it's from a technology side or from a product side. And again, when these things are automated, it becomes very easy to deploy them in this way. And again, it's just about limiting the impact. So if you've had no changes to a certain product, in the last day, maybe it's not worth running that test. Again, when it's automated, it's less of a question, but you can think about it this way. Okay. Now, how do we run the tests? Okay. First, we have to decide. Great. We know that we want to do it. Everyone's on board saying this is a great idea. How do we even get started? So the first is, what kind of tools and infrastructure and environments are needed? Are we running this on production? Is it running on QA because these environments are in sync? What tests can be automated? What can be manual? Okay, so let's move forward on this thought. Okay, so if we're going to automate tests, where are they going to be automated? So a lot of times we focus purely on web-based testing, which makes sense because there are a lot of web-based tools out there. There are some tests which may not need to be web-based. So if you're testing an S-based calc, whether it gets launched from the web or from EAS or from another tool, it really doesn't matter, because what you're actually trying to measure is the server. If you're trying to measure user response time, that's something else. But if we're just trying to figure out how long a calc takes, then whether it's launched from the web or from the server changes. So the tools you use and how you go about it will depend on what you're trying to measure, right? Another one is who owns the test. Does the business own it? Does a specific testing team own it? Do your consultants own it? Does IT own it? So having ownership is pretty darn important, especially when it comes to remediating the test or making changes or updating them with current versions. So getting this established is worth the time up front. Okay. And I think we've seen a little bit of everything. I think we've seen things that start with a dedicated team or a consulting group, and maybe then it gets absorbed into the business with help from IT or vice versa. Okay. Now, if there's something that can't be automated and we're doing the manual tests, very important to have it documented. Who's going to be doing it? What techniques are going to be used? If that person's not around, what skills are needed, and how are they going to be maintained and updated? So this is, again, the big question about having automated tests versus manual tests, is when you make changes to your data, do your tests need to change? If you make changes to your business structure, your organization, hierarchies, do the tests need to change? If the Oracle EPM versions change, do the tests need to be changed? Again, you have to be thinking about this so that when things change, you don't want to have the next run of your regression test return a bunch of errors and then you realize, oh, it's because we had these changes that we forgot to adapt our test to. So again, this is pretty standard stuff when it comes to ownership of these things. Okay. Available tools, again, you could do it manually. See a lot of people doing homemade solutions, which can be, crude but effective, but not terribly scalable or repeatable. There's a lot of tool suites out there, whether it's, HP LoadRunner or the Rational suite. Very few of them do anything that are Hyperion specific. The thing with Accelatis is that it's specific for EPM, or we have specific libraries for EPM, and more importantly, it's integrated with automation capabilities and monitoring capabilities, so it really ties it all together. Okay, so you've decided you want to do it, you pick a tool suite to move forward, you have an idea of how you want to design the test, how you want to execute them. Now you actually have to analyze the results, and this is where designing the test becomes important, because think about what the results are going to say. So here's an HFM example. If the way that the tests are designed, the results, the only way to quantify the results is an HFM consolidation is slow. Well, is it a specific application? Is it on a specific server? Is it with the database? So that's by having kind of a broad range of tests can help us pin this down. And this is where some stuff we're going to talk about with health checks come into play. It's that, sure, we can check whether a consolidation is slow or not, but just having that information isn't pinning us down to the source of the problem. So by being smart about how we design the range of tests and also having the monitoring in place, it's going to help us remediate the problem. Okay? So let's talk about remediation. So again, we can test, and one of the troubles I've seen is people will do performance testing, whether it's stress testing or regression testing, and not think about the reaction plan, where they plan stress testing for the end of a development cycle, and there's really no plan in place that if a problem is found, so a problem gets found and now it's kind of, it's all reactionary. So part of the testing plan should be, okay, what do we do if we find a problem? And this is where the test ownership comes into play as well, is if, it might be that, okay, if we come in with this range, maybe it was some type of anomaly, it happens, are you going to retest before you actually get people involved? Do you automatically get different teams involved? Who owns the problem and resolution, and so on. So just having that makes it much more methodical when a result is returned that you're not expecting. Okay, so let's take a look at an example. A lot of data here. Don't worry about the details, but this is a multi-user regression type test, and the idea is that we might want to test over time, and we also can call this like a concurrency test. It's picking those specific data points for S-base, for planning, for HFM and reports, and it's looking at certain things where you might want to do certain activities for a certain amount of time for a certain number of users, and our trigger criteria could be something like we want to make sure, if one or two things fail over a broad range of tests, maybe that's okay, and that's up to you to decide. And maybe the trigger point is if the performance is worse than 40% over our benchmark, we want to trigger. Again, that might be too generous, not generous enough, it's really up to you. But really determining what the test is and what the trigger criteria is, that's really designing the test. Implementing it is another story, but that's how we design it. And this is what the results could look like. A lot of crazy jagged lines here, but again, when you have an automated suite running it, and these are actual results from one of our clients, when you have an automated suite running them and looking at their results, it's going to pick out where the issues are. Okay, so this is what a graphical view looks like, pretty messy. Another way to look at this is through integrated health checks. Okay, so this is a little bit tangential to regression testing, but regression testing is kind of a broader view of integrating the health checks. So you could run something on a daily basis, or we could do it on a regular basis, and it's kind of the same thinking. It's what's the test, what's it telling us, and what's the frequency that we want to run it. Where something that's inexpensive, like a login or something like that, we might run every 5 minutes. For something that's more expensive, like running a book of reports, maybe we do that every 15 minutes or every hour or something. And in doing so, it marries up to what a single user, single instance test suite could look like. So similar to what we were just looking at before, which is a single user test for various data points, and define our trigger criteria. So maybe we're going to run this regression test. Maybe it's daily, or maybe it's an integrated health check that we're running every hour. But our trigger criteria is going to look similar, and it might be that, hey, if performance is worse than 40% of our benchmark 4 times in a row. So maybe we're not going to trigger if it's wrong just once. Maybe we want to rerun it, and if it's truly a problem because it happens multiple times in a row, then let's trigger. But maybe for something like login, boy, if login fails, we don't need to rerun it. We want to trigger right away. Then that's something we can do. So thinking about the trigger criteria, not just in terms of performance degradation, but also in repeatability, because again, anomalies do happen. Okay, and here's an example of some results for that single user test, and we can highlight where the problems are. And again, in an automated way, this would automatically be picked up. So based on that criteria we're set, we were looking for problems that were over 40% of our baseline, and this is what the data would look like. So it's one thing to look at it graphically. This is what the data would look like on the top. These are all the data samples, and at the bottom it's actually showing what the trigger criteria was and what the why it triggered and what the actual trigger value was. So really quickly, so for an OBIE dashboard, we said, hey, we're going to run this test, and if it's greater than 40% of our benchmark 4 times in a row, then boom, we're going to trigger. And you can see the data in the top row. Our benchmark was around 4 seconds, and we had 9 seconds, 9.19, 8.9, 8.7. So boom, it was 4 times in a row, greater than 4%. Boom, we're going to trigger. There's a problem here, something that needs to be investigated. Again, you could have triggered on one instance of greater than 40%, but now you might have a lot of false positives. So having a baseline of how your system performs, very important to making good decisions about how to set up the trigger criteria. Okay, but this is how you could look at the data. It might look like a graph, but at the end of the day, really, you're just going to wait for alerts. But if you want to dig into it deeper, you can look into data in terms of raw data, or you can look at it graphically. But you want to have the automation working for you in terms of running the tests and alerting to you as results. So this doesn't become a full-time job to manage your regression test. It's by exception. Regression tests run on their own. When there's a problem, you'll know about it, and then you can investigate it. Here's one more example, and this was from the webinar the other day, of how it could look graphically, where we have S-based planning and HFM regression test running once a day. And what you can see here is the HFM test in red and the S-based calc test in, the regular script test in purple are flat. But you can see that the S-based test for running a calc script started to deviate from the baseline. So this is something, depending on where we set our trigger criteria, we may have triggered on the first day where it deviated, or maybe we triggered on the 4th day. It all depends on the trigger criteria we set for us, and having a good idea of what our baseline is going to determine what makes sense for our trigger criteria. So I put this slide in here to really think about the importance of getting a baseline to know what's relevant as a trigger criteria. Because you don't want to have to spend the first hour of your day reviewing regression test results. It should really be automated, and the alerting should be built in. And if you're smart about how you build the triggers, then you'll spend very little time working on false positives. Okay. So again, I think I went over the 21 minutes, but not too much. Hopefully that gives you a fair idea of a little deeper view into regression testing. Again, there's an array of tools you can use to do regression testing. What we really want to convey, whether you're doing this for Hyperion, whether you're doing it for PeopleSoft or anybody else, and whether you're using our tool or LoadRunner, is really the thinking that goes on in designing a well-planned regression test suite. And from our experience, the people who have done that and really put the thought into it, they just had phenomenally managed environments, and they spent all their time on the business problem and a lot less time on managing the environment. So hopefully that's useful. If you'd like to talk in more details about regression testing or your specific case or how it can be implemented either with the Accelatis tool set or some other tool set, I'm happy to do that. If you think it'd be worthwhile to have an even deeper webinar, a deeper discussion on actual tool sets, that could be interesting as well. Let me know. We do have, we'll have more up on our website. You'll see other performance testing deep dives. Our next one will likely be baseline testing, but before that, on May 12th, we're going to have a webinar on integrating a help desk. And again, this will have a little bit about Accelatis, but a great deal about the role of a well-planned and built help desk in building a center of excellence, again, whether it's around Hyperion another product. So if you'd like a set of the slides, contact Cameron Morris. His email is here. Otherwise, you can always contact me, Jonathan Berry. Go to our website if you'd like to sign up for another webinar. But otherwise, thank you for attending, and let me see whether we have any questions at this time. Okay, let me... Okay, so there's a question about how we build in non-performance validation into your regression testing using your tool. Okay, great question. So, the way that Accelatis built our performance testing suite is, there's a lot of tools that do performance testing. What we did was we prepackaged our scripts, so whether it's running a financial report, whether it's running a calculation, and so on. So built into the script, we actually validate whether data is coming back, and there's a way that you can leverage our automation in conjunction with the test to check whether data cells are the same from one run to another. So if you'd like more detail on that, it's a little more than we probably want to spend time on here, but I'd be happy to discuss in detail about how we can do that with the tool. Okay, I don't see any other questions, but if anything comes up, again, please feel free to reach out, and thanks for joining today.